Hi all, welcome to my channel Tough Tech to Crack. So we are going to see the next session of our episode. We are going to discuss about the address resolution protocol. Okay, which is the Arp protocol, which is a widely used protocol in the networking things, networking standards, and in all the networking topologies. Okay, before going into that, so the address resolution protocol, as the name tells you that it is going to resolve some address and give us some solution for it. Okay, so in the network addresses, we have two types of address. One is the MAC address, which is the hardware address, and the other is the IP address, which is the network address. Okay, which is called the payload address. So just remember these two things before going into all the slides. So if you take the MAC address, it is of 6 octets. Octet is nothing but 6 bytes. Okay, so each byte, if you take one byte, it will have 8 bits. Okay, so the first 3 octets are the organization unique identifier. Okay, so which is defined by the organization. Say for example, Cisco or any Gigamon or any Nokia or any device will have, or any company, they will have some set of organizational unique identifier. So by saying the first 3 octets, we can decide which company MAC or which company device the it belongs to. So the other 3 octets is the network interface specific address, which is preloaded on the device, which is burnt on the device. Okay, if you take the first octet, it has 8 bits, right? The least significant bit, I mean the B0 bit, it can be either 0 or 1. So 0 means it is the unicast address, 1 means it is multicast address. Okay, the next bit B1, it is the globally, if it is 0, it is globally unique, and 1 means locally administered. Locally administered is like within their campus, they are maintaining this MAC addresses, local within the campus. Okay, then this is the, so MAC address is of 6 octets. The next is IP address format. IP address is of 32 bits. The first 16 bits corresponds to the network address, and the last 16 bits corresponds to the host address. Okay, so just think of these things. Then there are two subdivisions. One is the public address range and the other is the private address range. So the IP address is divided into class A, B, C, D, E, etc. So for each classes, we have predefined private address and public address. Public addresses, which means it can be routed over our internet. Private is within the organization. Okay. The next is LAN topologies. So if you take local area network is within a particular building or within a particular campus. If you take that particular building, so what are the network topologies or network standards that can be used? Layer 2 standards that can be used. So one such broadly used standard is the Ethernet standard. Okay, we can have Ethernet, FDDI, then we have what is that? Token ring, serial networks, P2P networks, point-to-point networks. Then so many layer 2 terminologies and layer 2 networks are available. But most broadly used is the Ethernet. So if you take the Ethernet frame format, it is again divided into two types. One is Ethernet 2 frame and 802.3 Ethernet frame. So if you take the first 8 bytes, they denote the start frame. Okay, start frame. The next 6 bytes denote the destination MAC address. The next 6 bytes denotes the source MAC address. The next 2 bytes denotes the type or the length field. Type defines what protocol address is hidden in the payload area. Okay, so the next is data, and the last 4 bytes denote the frame check sequence, so which identifies the error recovery and error correction of the particular frame. So these are the basics. Before we go into the address resolution protocol and discuss functionalities over that, I want you to understand first what is a MAC address and what it contains, an IP address, what is an Ethernet frame, so such things. So I'm just covering upon these things in these sections. So the next is the address resolution protocol. if you take ARP, address resolution protocol is, say for example, we have the X is one host, Y is another host, Z is another host. X will know about its own IP address and MAC address. But if it wants to send a packet to Z, it will know only its IP address. How it will come to know about the MAC address? So if it wants to know about the MAC address, then it has to send a predefined packet called as ARP, which is the address resolution protocol packet. This packet, what it does is like, it will ask, it is a broadcast packet, it will be sent to all the hosts checking for the corresponding MAC address belonging to that particular IP address. Say for example here, it will be sent, this particular packet will be sent to X. As you can see in the diagram, it is sent to Y, it is sent to Z, and since Y doesn't have the particular IP address configured, it will not reply anything. Since Z has the particular MAC address configured, it will reply with the ARP unicast reply. Okay, so this is what the address resolution protocol is. So, introduction of this protocol is, it is used to identify the upper level, it is used to identify the hardware address for the particular upper level addresses. Say, for example, we have IP, IPv6, so many protocol addresses are there, right? Protocol address is nothing but your IP addresses. So, IP is one of the protocol header. So, similarly, we can have IPX, SPX, TechNet, IPv6. So for these addresses, you need to, for all these protocol addresses, we should have some MAC address. So in order to resolve that IP address to MAC address, we are using this ARP. Okay. This is the, okay, here, when logical address is your, what is that, your IP address. When logical address is resolved to physical address, it is called as ARP. When the physical address is resolved to logical address, it is called as RARP, reverse address resolution protocol. If you take in this figure, this is logical converted to physical, it is ARP. And physical converted to logical, it is a reverse address resolution protocol. So where this reverse address resolution protocol comes into picture is in diskless machines, where you have a host and it gets its IP from another boot P server. So it will not know, it will know only about its MAC address, it will not know about its IP address. In that case, it will send a reverse address resolution protocol packet in order to find out the IP address for itself. Okay. The next slide is, okay, this is the packet thing. So your ARP request is a broadcast packet. It will be sent to all the host. So it is looking for a physical address of a node with this particular IP. So ARP reply, system B responds with an ARP reply, which is the unicast packet. Okay. So it will send with its particular MAC address corresponding to that particular IP address. So the next is, okay, the structure, ARP structure is, so you have a physical layer header, which is your Ethernet header, which is X bytes. Then you have the hardware address space. Hardware address space is the type of the hardware address, whether it is Ethernet or any other hardware is there. Okay, that is of 2 bytes. Then protocol address space, whether it is an IP or IPv6. So that is of 2 bytes. Then hardware address byte length. So if you take hardware address, it is of 6 bytes. So it will be 6 here. Protocol address byte length, it is 32 bits, which is 4 bytes. It will be 4 here. Operation code, whether it is a request packet or a reply packet. Hardware address of sender, which is the MAC address of the source. Protocol address of sender is the IP address of the source. Hardware address of the target is the MAC address. In the ARP request packet, it will be it will be zeros. Okay, because it will not know the MAC address of the target. Target is the destination. Protocol address of the target will be known. Okay, so our finding is like to find out the MAC address of the target. So this is what explained in this slide. So in another ARP is proxy ARP. Proxy ARP basically it has see what it does is we have, instead of the destination replying to the ARP request, we have in between a router which takes the ARP request and it will answer to the, and it will give an ARP reply. Okay, so the ARP reply will not be sent from the actual destination, but before that the router gets the ARP request and it will frame an ARP reply and it will send to the sender. Okay, it will send to the source. So in the ARP reply, the MAC address will be that of the router MAC address. So basically, this is scenarios, the use cases for this proxy ARP are in network address translation, where the router wants to translate the incoming IP and it wants to translate the incoming IP to another IP and send to the host. In that cases, the proxy ARP will be, the router will get the ARP request and it will translate, get the ARP request and it will answer on behalf of the end host. In another scenarios, for security purpose, in order for the host to not be prone to any security threats, so the router will act like a firewall. So these are some of the scenarios. Okay. So this is the another one thing is reverse app, as we have told, as we have discussed before. See, the device needs to know the IP address once the MAC address is known. So that is the, it will send the RARP packet to the server and it will get the reply, IP reply for the particular MAC. Okay, that's it. This is the address resolution protocol. Basically, it is a very, very basic thing for any network communication or traffic thing to happen. So this is a surprise test for you. Please answer the questions below in the comment section. So the first question is, ARP works under which layer of the OSI model? This we have discussed in the first slide. So please think and answer. Why a IP address needs to be mapped to a MAC address? Why can't the MAC address itself be represented using the IP address? Okay, the next question is, will a host update its ARP cache upon receiving any ARP request? Okay, so please answer these questions in the comment section. Thank you. Hope this session was very interesting to you. We will meet again with another set of new interesting videos. Thank you.